Hello, this is Mrs. Carnahan, and in 8.3 we'll be talking about special right triangles. So the first type of special right triangles is a triangle that is isosceles. It has 45, 45, and 90-degree angles, and the legs are congruent because it's isosceles, and the length of the hypotenuse is square root 2 times the length of the leg. Now this comes from Pythagorean theorem. It's kind of a shortcut in solving these when we sometimes only know one of the sides. If we know two of the sides, then we could use Pythagorean theorem to find the third, but a lot of times with these types of triangles it's easier to use that the legs are congruent, so they're the same, and then the hypotenuse is the length of the leg times root 2. So when we're solving these, you'll see all these boxes below. Before we move on to doing some examples, I want to talk about what's going to go in these boxes. So over here, and I'll leave this up so you can keep filling in the definition and pause if you need to. So in this box, because I have 3 sides, we're going to be comparing those 3 sides. And in order to compare them, we use the angles. So I'm going to start with the angles, and this will be the same every time. So this is just a generic box that we're going to use every time. Now in the middle is how we're going to solve for those sides. So we're just going to put the theorem, oops, I meant to put 90 on that last one. This should be 90. And so if you look at the triangle over here, my 2 angles are 45 degrees, and I have my 90-degree angle, and the sides across from the 45-degree angles are my x's, so I'm going to put that in the second column. So x, x, and then across from 90 is x root 2. So I'm going to put in just x root 2. Then we're going to use the third column for different problems. So we're going to plug in the numbers that were given and use that to find the other sides. This is just one way to do it. You don't have to use this box every time. It's just a recommended method to organize the information a little bit better. But you can just do it how you would like. Alright, but this will stay the same how I have it for every 45, 45, 90 problem. And we'll do the same thing for 30, 60, 90, so it'll be pretty similar with different numbers and different variables in the middle. Alright, so I need to start by filling out my box with what we just filled out. So for a 45, 45, 90, I have x, x, and x root 2. In this case, I'm given that side is 9. It helps to fill out missing angles sometimes, so that way you can look across. I know across from the 45-degree angle is 9, so that's going to go across from 45 in my box. So I know that the x is 9. That means this one is also 9 because they're the same, so this leg is also 9. Now I know that x is 9, so all we have to do to find the hypotenuse is take 9 times root 2. And that's it for this one. Across from the 90 is 9 root 2. So across from 90 in the picture is 9 root 2, which is what we were trying to find. So that means x is 9 root 2. And just a side note here, the x in the picture is not the same x that's in my little chart that we made. The x in the chart just helps us to find the hypotenuse, or maybe we need to find the leg and work backwards, which we'll do some examples of. But the x in the diagram is not the same as the x in the picture. Okay, it's not the same x. I need to figure that out later by going back and labeling my picture. So let's try another one. I'm going to fill out my table the same way again. So 45, 45, 90, x, x, x root 2. Now you'll see these have some root 2's in the picture, but we still use the same process. Look for our angles. These are both 45. Now across from the 45-degree angle is 6 root 2 for both of them, right? Because those will always be the same. So that if that one's 6 root 2, this one's also 6 root 2. Now that's my x. So in this case, I need to take that whole thing and we're plugging it in for x right there in front of the root 2. So I'm actually going to have 2 root 2's next to each other. So it might help when we write this. We have 6 root 2 times root 2. I have that 6 root 2 I'm putting in for x, so I have 2 root 2's right now. Now I need to simplify those. Root 2 times root 2 we talked about is root 4. And then square root of 4 is 2, so 6 times 2 gives me 12. So that means this end box here, if you wanted to write the work to the side and then just put your final answer in the box, that might be helpful, but that box is 12. So across from 90 is 12. So up here across from 90, I get 12, which is my x, what I was trying to find. So x equals 12. Again, I like to go back to the picture and label in order to figure out what variables I was looking for using what I got in my chart. All right, let's do a couple others so we can work backwards. In those previous two, we were given the legs and we were finding the hypotenuse. In these two examples, we're given the hypotenuse and now we need to find the legs. So I'm going to again just start by filling out my chart. 45, 45, 90, x root 2. That's always going to be the same. That's never going to change. Now, rather than having what's across from 45, this time I have what's across from 90. So across from 90 in my chart is right here. That's going to be 8. I'm going to erase the arrow so we can use this. I need to figure out what is the x in my chart in order to get what's across from 45. So this is really an equation. These two things are equal. So I'm going to solve this equation. I have x root 2 equals 8. To solve the equation, I need to divide both sides by root 2. And we get x equals 8 over root 2. But oh no, I have a radical in the denominator. So this is why we talked about rationalizing the denominator. I need to get rid of that, so I'm going to multiply the top and bottom by root 2. I'm just going to bring that down here. We get 8 times root 2 in the top. In the bottom, we get root 2 times root 2, which is root 4. You can simplify that now and just change that to a 2, because root 4 is 2. And then remember, we have to simplify what's outside the radical, so 8 divided by 2 is 4. I cannot divide the radical, that stays root 2. So that means x equals 4 root 2. So back in my chart, across from 45 is 4 root 2. So that goes for both of them, which means that is my leg. So if I go back, across from 45 is a, that is 4 root 2. Same thing this way, we have a, that is also 4 root 2. So a equals 4 root 2. Okay, remember the x in the diagram is not your variable in the picture. It's just a way to help us figure out the side across from 45 and the sides across from 90. Okay? All right, so let's do one more. This time we're given 6. Let's fill out our chart. So 45, 45, 90, x root 2. That's always the same. Now I just need to fill in what I have. So looking at my picture, the only side I have is across from 90, which is 6. So 6, I'll use blue there. 6 is across from 90 in my chart. So there's 90, so across from that is 6. So now I have another equation like the last one. I have x root 2 equals 6. I'm going to divide by root 2. That is a 6. It looks kind of like a B, sorry. That didn't help. All right, so now I have x equals 6 over root 2. But again, I have to rationalize the denominator. So we multiply top and bottom by root 2. We get 6 root 2 over Square root 2 times square root 2 is 2. And then I need to divide what's outside of the radical. So 6 divided by 2 is 3. And then the radical stays, root 2. Now that's my x in my chart. So that would be 3 root 2, which makes this also 3 root 2. And then I'm going to go back to my picture. Now across from 45 was 3 root 2. Same thing the other way. Across from 45 was 3 root 2. So b equals 3 root 2. Okay, again, the variable in the chart there is not the same variable that's in the picture, even if the variable in the picture is x. Okay, so don't get that confused. All right, we're going to do a couple more examples together, and then you're going to try some problems on your own. These two problems have to do with squares, because if we have a square, I'm going to draw a square over here. If we have a square, it says find the length of the diagonal. I'm going to draw the diagonal, but a square has all 90-degree angles, so I'm going to draw that in as well. If I draw the diagonal, remember back to chapter 6 when we talked about properties of a square, and properties of a rhombus is that the diagonals bisect opposite angles. So if that is a 90-degree angle, that makes these all 45 degrees. So this creates, one diagonal creates two isosceles right triangles with 45-degree angles. So it's a 45, 45, 90. This one gives me the perimeter, and I need to find the diagonal. So if the perimeter is 48 and all of the sides are congruent, all I have to do is divide by the 4 sides to get each side. So each side is going to be 12. Now that I have the sides, I'm going to start filling out my picture, or sorry, my chart. I'm trying to find the diagonal, so I'll make that x. So in my chart we have 45, 45, 90, and then we have x, x, x root 2. So in this case, our 12 is across from 45, if we look back at the picture there. So across from 45 in my chart is 12. And then this one's just a simple, take the number and plug it in for x into the x root 2. So we'd be left with, sorry, not x, 12. I got to plug in the 12 for x. So 12 root 2. So the diagonal is the one that's across from 90. That would be 12 root 2. Because if you look back at the picture, across from the 90-degree angle is the diagonal in that triangle. All right, let's try one more just like that. So again, we have a square. Same thing, that creates a 45, 45, 90 triangle. There's my right angles. The perimeter is 20, so if I divide by 4, that's going to give me each side, because there's 4 sides. Each side is 5. I'm going to write in the angles. These are 45 because the angles are bisected by the diagonal. Again, I'm trying to find the length of the diagonal, so that'll be my x. Now let's fill out our chart. So we have a 45, 45, 90, and then x, x, x root 2. Now in this picture we have across from 45 is the 5. So 5 goes across from 45 in my chart. And then this one, I have x now, so all I need to do is plug in x in for x. So 5 root 2. And that's the one across from 90, which is what I wanted. Across from 90 is x. So my diagonal is 5 root 2. Okay. So when you have a square, remember that creates those 45, 45, 90 triangles, and we can use the 45, 45, 90 triangles to find the diagonal, or work backwards even to find the sides if we were given the diagonal.